Thank you all for staying. You have excellent stamina. I'd like to close by talking about something wonderful. So, 20 years ago this year, an AI beat a grandmaster chess player, Garry Kasparov. And just a few weeks ago, an AI from Google beat a grandmaster Go player. The number of potential moves in a chess game has been equated to the number of atoms or the number of grains of sand on beaches. The number of moves that are potential in a game of Go are equal to the number of atoms in the universe. So within 20 years, the technology of artificial intelligence has progressed from a point where the system that beat Garry Kasparov was a brute force decision tree. Essentially, every move and every chess match had been coded and put into a big supercomputer that could go through and evaluate every move using a brute force technique pretty quickly. And unfortunately, that AI system, although it was a great demonstration of the potential of computing power 20 years ago, was not generally repurposable to solve problems like cancer or world hunger. The technologies behind the types of machine learning platforms that are available today are generally repurposable. So the system AlphaGo from Google that beat a grandmaster and beat quite handily is generally repurposable, thank you, to solve other problems. So taking a step back, what is machine learning and how is it different than a lot of the technologies that we've been talking about today? Machine learning and developing a system, a game on a machine learning platform is less like programming and a lot more like testing or teaching a child. And to put it simply, machine learning and a machine learning platform is software that learns and produces, so produces just like classic software. But this is a software system that learns and produces without being explicitly programmed. And if you were classically trained as a software engineer or a code developer, learning machine language is a little different, and sometimes a lot different, because you're not explicitly coding, you're not explicitly controlling the environment. It's more like you're guiding a very naive child that can think really, really fast. So what I'm going to do today in this presentation is I'm going to go through two case studies, and I'm glad I'm following the indie panel. I'm going to go through two case studies where indie game devs have used machine learning in very different ways to solve some very interesting and systemic challenges that we face as an industry. But an interesting thing about machine learning is machine learning platforms like from IBM or Google or Facebook or Amazon or Microsoft or Tata are already very mature technologies, and these are technologies that have been used to, in our case, solve some pretty significant medical problems. Our Watson technology, the first use case after the Jeopardy challenge in 2011 was to ingest and understand every word that had ever been written about any form of cancer, and then understand that massive body of knowledge and then be handed over to oncologists to be able to help individual patients and entire populations be treated better, generate better outcomes. So whereas the game industry often, like VR, like 3D, and like social media, will adopt a technology very early in its infancy, and the industry will see the potential of a technology. This is a technology that has direct applicability to the games industry that is being matured outside of the industry, and we're going to benefit tremendously. If your QR scanner works, while I'm talking, you can play with a particular demo. This demo is a personality insights generator. So this is an AI that you can have read all of your tweets, and then the AI understands language and has been trained on clinical psychological methods, and will actually give you a psychologist's personality profile based on your tweets. And it might be something that would be fun to do while you're listening to me talk. So I'm going to go through 2 case studies. I've got lots of case studies. There'll be a bunch of links at the end. But one of the things that we started out looking at is, one of the most important challenges in the industry is, how do you get game design right? How do you create a game that engages the player as an individual and keeps them interested? So as a game designer, game designers kind of have a mega challenge and micro challenges. And in this context, we're thinking about the game design of a simple puzzle game. And we chose this case study because it boils down a really fundamental problem. How do you engage? How do you retain? How do you convert players? And boils it down to something simple that people can get both their heads around, how machine learning can be applied, and that we could actually validate, is this, can machine learning actually be applied to game design? So the big challenge a game designer has is, how do you create a progression curve, an extended experience in your game, so that people start simple and you're progressively giving them more challenge. Everybody knows that a linear progression curve leads to boredom and abandonment pretty quickly. So what does the engagement curve look like? Do you give them 2 hard levels and a simple level? Do you give them one simple level and then one hard level? And what is simple and what is hard? And then on the individual level, you're designing individual experiences. In a puzzle game, it's 30, 60, 90 second experiences each puzzle. You give each one of those puzzles kind of a seeded experience level, and then you create all this content, 200, 300 levels, and then you put them in order that you think the average market would find interesting. And effectively, you're making 2 pretty big assumptions that the game is going to live or die on. And that is, this progression curve that you designed is actually interesting, and the content you've created actually can fit and deliver that designed experience. So the first case study here from SparkPlug Games, and shout out to John O'Neill, the CEO of SparkPlug Games. This is a company we work with in a lot of our game projects, independent game developer. Was developing a rather simple puzzle game called Plight the Zombie. Your job is to go around and eat brains. It's standard puzzle game fare, and an ideal test bed where they had their design progression curve and a couple hundred levels. And the challenge was, can we use machine learning? But then, what kind of data do we collect, and how much data do we need to collect? The indie panel talked a lot about, when you're working for a big studio, you've got all this behavior data. But what if you're an indie and you don't have a lot of player data, or you're working on something really new and you don't know what people are going to like? With machine learning, you have the opportunity with a simple API call, collect all your telemetry data and send it to a machine learning system, and have the player's own behavior tell you what they like. And that's kind of the goal for this particular project. So we started out with 3 simple variables. One, variable was the seeded difficulty level for each level in this puzzle game, and then 2 pieces of data that came from the players, like how long it took them to complete a level and how many times they retried. So, following Guy Kawasaki, never put words on a slide. This is a lot of words. And I'm now so proud I'm the first and only presenter today that actually is showing code, or maybe the second. But this is actual code from Unity making a single call to a machine learning platform to have a machine learning platform evaluate all of the players' data, so all of the players' telemetry, and based on that telemetry, pick the best next experience. So some players naturally get the mechanic of a puzzle game, some players don't. So again, getting back to I want my players to have an engaging, lasting experience. A player that's having a hard time with my game mechanic, my progression curve may still be accurate for that player, but it may be expressed in the simplest sets of puzzles. So if I'm scoring level difficulties, the difficulty of levels on a scale of 1 to 100, it may be that players that are having a hard time with my mechanic are going to be engaged by levels that are scoring a 50, whereas people that are finding my puzzles real easy may be engaged by giving them difficulty that range in the 70s to 90s. So one of the first things we found out is that, like with Google Maps and like with many microservices that are available on the internet, machine learning platforms often express their interfaces as REST-based APIs. And REST, if you've tried to integrate a game engine with any public microservice or REST-based API, you need to write a lot of frameworks. So that was the first challenge. Once we got over that challenge, the APIs we found were really simple to use. And so integrating with a machine learning platform was literally 20 lines of code. And that 20 lines of code took an indie game, a simple puzzle game, from crossing your fingers and hoping that my levels, my difficulty levels for my were seeded correctly and my progression curve was accurate. Another thing we didn't know when we tried this experiment was, our assumption was you're going to need lots and lots of data in order to make good decisions, even on an individual basis. And our first assumption was this is probably not going to work because you won't be able to make a good decision until the players played 30 or 40 levels, and by then you've already either won or failed. What we found was, in this game, there were 3 tutorial levels and 2 dead simple levels. And we found that a machine learning platform, and in this case, we're using an API that will not give you the best answer, but give you a range of answers and let you pick one of the top 3. It's called decision analytics. We found that after the 5th bit of telemetry, so the 5th playthrough from a player, the machine learning platform was already able to pick content that was appropriate for a particular player. So, our big aha was that machine learning platforms were able to learn and make good choices very quickly. And this was really good news for us because it means you don't have to use them as often, and they're a lot more powerful than we assumed. So some of the next steps, this was a really simple case study that we worked through, just trying to make sure that we could deliver content that was appropriate to an individual user after sensing what they felt was appropriate. The next steps then became really obvious. Let's take all of the telemetry from our entire player community and validate the difficulty seeds of our individual levels. And let's validate our an entire game design, that progression curve, what type of behavior, what types of levels are people actually responding to, which ones are they repeatedly playing over and over, but continuing, so that showed that there was enough difficulty that they were willing to retry a failure and felt the game was interesting and continue, or was it people wanted to play through puzzles as fast as possible. We can use the same API and the same technology to validate game design decisions. And with a game where the content is dynamic and can be delivered at runtime, you can actually tailor game design and tailor levels to an individual's experience. So the next case study we were working on is kind of the opposite end of the spectrum in game design. Can you create a character, an NPC, in a game that you could say passes the Turing test, but in entertainment, the character has to not only pass the Turing test, the character has to interact with you in a way that you find interesting, that you develop an emotional connection with this character. A character that you could hold a conversation with like you would any other person, and that personality elicits responses and behaviors from the player, but also supports mechanics in a game. So again, the QR code and the link here, the game is called The Suspect, and if you Google the Suspect, you're going to go all different ways. It's www.thesuspect.com. And this game, the premise is somebody walks into a police station with a bunch of pictures and a bloody hat, and immediately gets put into an interrogation room, and just like every episode of Law and Order, you're given the job of finding out what happened. And that's the premise. That is the extent of the setup. You are then given a box, and you hold a conversation with this character. And this character is completely fictional and completely interactive. And you're interacting with this character in free-form English, and it is as wide open as Grand Theft Auto or any other completely unrule-based game. Now, there are game mechanics wrapped around the interaction, but the idea is you're trying to extract a set of information from a personality that isn't necessarily cooperative. So the developer, again, Guy Gandy, was the lead developer for The Suspect, and a leading mind in the development of conversational-based interfaces or chatbots. He has a history of developing conversational-based interfaces for primarily television properties, and has some great stories about if you're working with a television, mass media property, television or movie, conversational interfaces can actually grow an audience between productions. But the idea here was they wanted to create a game around a single personality, and using a trope and a mechanic that was very well known, the police procedural. And they started with a single writer that wrote effectively a FAQ, frequently asked questions. You know, if the character was asked this, what would be the response? The kind of thing that you would normally write for a standard decision tree-based dialogue interface. And they use that basic fact to do the preliminary training of a conversational AI, commonly called a chatbot. But this conversational AI had more capabilities than the average chatbot. Had the ability to not only understand language as it was being talked to, but also understand free-form language that would inform the personality. So the second thing this developer did was brought on a prose writer that wrote the entire backstory in free-form prose for this particular character. Where they grew up, how old their parents were, what their favorite color was, what their high school experience was, so that when you asked a question of this particular character, the answer might be made up of some elements of the fact, or the real piece of hard data that you were trying to extract, and some elements of this character's backstory. They love the color blue, but any mention of rosé, reminded them of their first bad date. And if you ask them about a shirt and you described the color as rosé, the personality would then shut down and stop answering your questions. So they got a great backstory, and they got the elemental questions for this experience, and then we all have our own hierarchy of needs and our own goals, and the way we respond to new input and repeated input. The third thing this developer did was actually create a mind map in a standard piece of mind mapping software that described this guy's hierarchy of needs, what his goals were, why did he walk into this police station, how did he respond to repeated questions. This particular guy was quite snobbish. If you asked him the same question twice, he'd give you a good answer the first time, but if you asked the same question again, he would shut down and stop talking to you. If you rephrased the question, and this is the power of natural language AI, if you rephrase the question, but it was the same question, you get the same result. So through this development process and the focused development of the personality was about 4 months, and elements of the game also include video and a second screen experience. So there was a lot of development creating video content, and the secondary screen experience took them about 1.5 years. And as Guy describes it, it was, can we throw everything we can think of, video, audio, history, mind map, as well as straightforward Q&A, into an AI and really get an engaging experience? And I recommend everybody try this out. In my humble opinion, they were tremendously successful. And we hope, I wish I could talk about it today, but we hope to have a very similar announcement of a conversational interface and a major title within the next month. But this is, we've got some members from Wargaming, and Wargaming was brought up early. Think about if you were playing World of Warships and you were piloting a Russian cruiser, and you come across a British battle cruiser, and you turn to your salty 20-year Russian Navy vet who's an expert in Russian history and ask him what he should do, and he rattles off, this particular engagement that happened 30 years before, where a Russian hit a British battleship right in the rudder, where all the where all the British battleships are weak. That's the type of conversational interface and the type of capability that we're looking at just now being able to provide from the games industry. So again, some interesting statistics on the screen about using conversational interfaces to support other medium, and talking about doing contract game development. A lot of major media properties are now turning to indie game developers to create these side experiences, or these second screen experiences for something that's weekly episodic and has a 4-month hiatus. And we've seen early experiments actually from the telenovela industry, where conversational interfaces on the web and mobile can actually not only retain audiences but increase them. So, if you're an indie out there trying to think about what kind of work you could do and specialize in, and still stay within media and games, This is an area that is growing very rapidly, and there's a tremendous amount of demand from other parts of the entertainment industry that would understand games and games development more than, say, industrial sector or the car sector. So I went through 2 case studies of machine learning being used very differently in games. I've got 5 I know of in detail, and there are a lot more. I mentioned the AlphaGo project, which is a tremendous step forward in just the fundamental capability of machine learning in games. Project Ares is another game where the AI actually will throw cyber attacks at you, and it's a game, a serious game to train people on how to respond to cyber attacks in corporate IT. Guy Gandy it just wrote a piece for the website How Do We Get to Next, which is part of the Bill and Melinda Gates Foundation's outreach, and he wrote a great article on the philosophy and some of the underpinning design elements of creating conversational games. I highly recommend going and reading it. We did something interesting with a mod, Minecraft, in a underprivileged high school, using Watson to train kids to understand a disease so that they could represent it in a game. So what does measles look like, and what kind of tools would you need to craft in Minecraft to actually go defeat measles? Some other, Mar.io is a great video tutorial on the programming of neural networks. The author goes through using Mario to train a neural network from the ground up. And all the neural network can see is what's on the screen. And the neural network has something like 8 buttons it can press. And that tutorial takes you through and gives you a great understanding of genetic algorithms and how programming these new systems is really different than sitting down and coding. And it shows really visually and really simply, and actually in a quite fun way, how to use genetic algorithms to train an AI, in this case to play a game, but you can think about how AIs can learn to be avatars. And then another one, a completely different area of the business, a company called Artomatics is using AI to make landscapes better. So they started out being able to dynamically and systematically remove seams and textures. So their demo is texturing a desert with 3 different tiles and generating just a really horrible experience, and then running it through their machine learning platform to detect edges and smooth, and using just 3 simple tiles create a really beautiful landscape. So I highly recommend you check out Artomatics. It's the use of AI and the use of a machine learning platform actually to accelerate the creation of content and reduce the cost of creating that content. And I know I've been standing between you and beer, and I thank you very much for being a great audience, and enjoy.